All right, thanks a lot, Shannon. Good to be back with everybody today. We have the next panel is assessment of wildfire exposure to public water supply areas. I think Mike touched on this yesterday in his introduction that this was an add-on to the project that we got. Basically, I think as a result of connections that Jeff Behan had, Chris Ringo, one of the presenters, happens to be his neighbor as well. This year of all years has highlighted the importance of considering wildfire risk with respect to drinking water supplies. So I am happy to have two of the people who worked on that study with us. There is a chapter in the book on this, an overview chapter, and then there are individual fire exposure risk maps for all of the 156 community water supplies that will go into the atlas. So let's get started. Michelle Day is a biological scientist with the Fires, Fuels, and Smoke program at the U.S. Forest Service's Rocky Mountain Research Station. She helps to develop and test quantitative models to understand management trade-offs at multiple scales, especially in the context of wildfire transmission to communities. Chris Ringo is a senior faculty research assistant in the College of Agriculture at OSU. He has been a spatial analyst, programmer, and manager for 30 years in a variety of natural resource applications. So I will turn it over to you two, and I think that Michelle is going to start it off.
Thanks, John, and thanks everyone for joining us today. You are saving me a few minutes because I was going to talk about how this was an add-on, so I can jump right into things. Chris and I are going to be tag teaming this presentation. I'm going to start with some background and context information, and then Chris is going to take over presenting our main methods and results, and then I'll jump back in and talk about some conclusions. And then we're hoping we have time to talk about the 2020 wildfires in the context of this work. There we go. Okay, so I'm sure we are all familiar with the multiple wildfire risk maps that exist today, particularly for the Western US. This is obviously a continental scale wildfire risk map. There's also regional scale maps like the quantitative wildfire risk assessment that was completed for Oregon and Washington. And if you zoom into the red spots on this map, you're going to find spots that have a high probability of wildfire and a high likelihood that we're going to lose some value of interest, some highly valued resource. Our team takes a different approach to wildfire risk. We focus instead on the source of risk, so where fires ignite and then spread to adjacent areas, coming at it from a forest management in particular perspective about where we can mitigate wildfire spread. So the source of risk is considered the third dimension of risk. So probability of a wildfire event and the consequence, the loss of some highly valued resource. The first two dimensions, the source of risk is the third one, and this is really well defined in other natural disaster research like pollution. Where is the source of pollution? How does it spread? Maybe through rivers and waterways. And we're all way too familiar with risk with transmission with disease. Where does a virus start and how does it spread through the community? So the idea is that you might not be treating the problem if you're not examining the source of that risk. And it's both sides of the problem, right? So this is additional information in mitigating wildfire disasters. This is a picture from the Camp Fire in Paradise, California. This community was almost completely destroyed, yet the surrounding vegetation is intact. So understanding your risk in one spot on the ground is not the whole story. These large fires that spread long distances, thinking about the source of risk is also going to be critical for wildfire mitigation. This is an aerial view. Sorry, I'm trying to get my video out of the way. Oh. An aerial view of the wildfires in 2020 and how they spread long distances. So these fires are crossing ownership boundaries, different vegetation types, boundaries based on fire management, how different agencies manage fire, topography, all of this contributes to how wildfire spreads across the landscape. And this complex figure is actually a wildfire transmission diagram for the state of Oregon. The nodes are the major ownerships in Oregon, and the arrows are wildfire that's being transmitted from one to another. So the Forest Service is transmitting fire to private lands, and private lands are transmitting fire to the Forest Service. So this shows the complexity of the wildfire problem and how much of a cross-boundary and collaborative problem solution is going to be needed to manage wildfire. So our goal is to assess wildfire exposure to public water supplies with the goal of providing some decision support information and hopefully creating outputs that allow the prioritization of cross-boundary shared stewardship projects with the goal of reducing wildfire exposure to water supplies. We did this by leveraging wildfire simulation modeling. We're simulating tens of thousands of wildfire scenarios. And these are based on large wildfires that escape suppression based on historical fire size distributions and fire weather. And this is important because this work was completed before the 2020 wildfires. So those kind of events are not in the historical record that we have to build these models. And I also want to point out that we are predicting exposure, not loss. So we're merely saying wildfires are likely to ignite in these places and spread into public water supply areas. We're making no predictions about some of the things the other panelists have talked about, soil water erosion, culvert failure, changes in water yield. We're not going into any of this. We're simply talking about exposure. Hand this over to Chris.
So I'm just going to go through real quick on the kind of nuts and bolts of the sorts of things that we modeled and what we put together in the publication. And then if we have time, like Michelle said, maybe we would have a few slides on the 2020 fires. So all told, this library of modeled fire perimeters and ignition points impacted the 100, well, John said 156, maybe this is wrong, 159, somewhere in there, around 150 different public water supply areas that we looked at, and about 800,000 simulated wildfires that hit those public water supply areas. So for each of those public water supply areas, we developed a profile based on the number of fires, the area exposed by fires, the ownership, kind of breakdown of all the sources of those fires, how frequently they experienced fire, and how intense those fires were. So the first thing is who owns the risk, like Michelle said, where did the fires start and spread? So here's an example of a fire perimeter in black. This is the blue boundary is the public water supply area for Riddle, which is down in Southwest Oregon. In the backdrop is the ownership. So I kind of chose this one. It's a little more complicated than, not unusually complicated in terms of the checkerboard of BLM and private industrial with a little bit of other private and state ownerships thrown in there. So this is an example of a fire that would have started off outside the public water supply area on BLM land and spread into the public water supply area. Another example of a different fire may have started inside the public water supply area, this one on state land. So we record each one of those for all these 800,000 fire perimeters. We calculate the area that was exposed within the public water supply area. And again, when we say exposed, we just mean area. This is the area within the perimeter. We don't make any predictions about the damage done by that supposed fire. We calculate the number of fires. And again, this is over 10,000, at least 10,000 fire seasons, contemporary fire seasons that are modeled. And from that information, we create what we call a fire shed. And this, so for every point in this raster here, it shows the average size of the fire, the average burned acres within the public water supply that ignited at that point. So you can see that the fire shed for this Riddle water supply is quite a bit larger than the actual water supply area itself. And then lastly, one of the outputs of the fire simulations is the modeled intensity of the fire, which is measured by flame length. And so this, this raster here, you can see that it varies a lot within any area. And this is an average over all of those simulations over 10,000 years of simulations. And so we take all these measurements, and what we did was we created an atlas. And John mentioned this is going to be an electronic appendix to our paper in the trees to tap volume. And so this pulls together all that information we were just looking at. So you can see the fire shed there, a rather mind-bending view of the ownership in and around that fire shed. Over here in the pie charts, you can see the average flame length. So when you get above, I mean, it's generally 8 to maybe over 8 to 10 feet is going to be considered a pretty severe fire. And then how many fires hit this area within that time frame. And then in the ownership histogram here on the bottom, this is the ownership breakdown of ignition sources that burned within or into the public water supply area. So in this particular case, it's pretty much a 56% BLM and 36% private industrial, which are the major landowners within this particular fire shed. So when we zoom out and look at the big picture, this is a map we included in the paper, which was the percent of the public water supply areas that were burned in over a 100-year period. And when you average over that amount of time, I mean, it kind of washes out some of the results. So really at the upper end, maybe 18% was the highest, and that's over 100 years. So City of the Dalles was the biggest, and this chart also shows the number of land tenures that if you were going to try to mitigate the exposure, and you have to pull in all these landowners, there's, for the City of Dalles, for instance, there's seven different landowners that own some of that risk. And then it goes down from there. So another way to look at it is the maximum simulated fire size within that hit each one of those. And this is kind of a different, if we look at the average, whoops, sorry, wrong way. You can see that I'm in trouble with my arrows. Okay, let's stick with the maximum fire size. This is pretty much reflected in all of the modeling that we've done. Southwest Oregon is definitely where the largest fires occur. Northeast Oregon, and some along the Eastern Cascades too. So when you look at it this way, pretty much all of the high risk from a fire size standpoint occur in Southwest Oregon, with one exception, the Prairie City one out here by John Day.
So in the end, what can we say about this work collectively, and sort of related to what I talked about in the beginning, is this is a collaborative cost boundary problem. So it's really going to require us to come together to mitigate wildfire exposure. 1/3 of the public water supply fire sheds had greater than 3 owners contributing, fire to that water supply. And as Chris noted, some of these large fires is up to 7. And these are coarse groupings. So when you start thinking about smaller scale, family, smaller private industrial owners, different Forest Service districts, that just makes the problem a little bit more complex. And I think the big takeaway is that the scale of planning needs to match the scale of the problem. So this is an example from our community wildfire exposure work. These red blobs are the fire sheds around each of these 5 communities in Central Oregon. And some of these areas contribute fire to multiple communities. So taking a community by community approach is really inefficient. And speaking of scale, I'd like to kind of jump into the 2020 fires, Chris, so that we can show some of that work.
So this is just that previous map that I showed with the perimeters of the major fires in Western Oregon that happened last September and October. When you look at the fire sizes for Western Oregon, they're pretty unusual, but not unheard of. When you look at the backdrop of the maximum simulated fire size, you can see they're kind of in line. I mean, in this light blue area where the Beachy Creek and the Lion's Head hit, I mean, up to 200,000 acres is not unheard of in our simulations, and that's about, about the size of those two fires. I think the thing that was really unusual in this fire season was that kind of Santa Ana type wind event that we had that just blew all these down to the west, which is a pretty unusual weather pattern for that time of year. So when I overlaid these fire perimeters with our public water supply areas, there was about 800,000 acres worth of fire that overlapped the public water supply areas, which accounted for about 6.5% of the 150 some odd public water supply areas that we were looking at, which doesn't sound like a lot, but it's a lot for 1 year. I mean, there was some, as we all know, there was some pretty serious damage. When we look at which ones got hit the worst, definitely Brighton Bush, Hot Springs, small community public water supply got overrun by the Lion's Head fire completely. And by the Beachy Creek fire, it was the Lions Bahama. City of Malala, Detroit got hit by the Lion's Head too. So I'm just gonna zoom in a little for a few slides here and look at the Beachy Creek fire in particular. So when you look at the public water supplies in this area, the dark perimeter is where the Beachy Creek burned. And it impacted mainly the Lions Bahama, but also Gates, City of Gates, Mill City, and the northern arm there went up through the Malala watershed. So if you look at our atlas page for that particular fire or that particular public water supply area, the Lions Bahama Water District, you can see that the Beachy Creek pretty much ran through almost the entire thing, over 80% of the area. Now this, the Beachy Creek fire was actually a couple of fires that grew together. I mean, it started out one in the upper end of the Lions Bahama watershed is the Opal Creek Wilderness, where it started in really steep wilderness area. And the Forest Service tried putting it out, had dumped a ton of water on it, but it was smoldering in the dumps and they couldn't really do anything about it. But then this huge wind came along up to 75 miles an hour, I think, gusts, and blew it westward. And at the same time, the San Ian Canyon fire was started by a bunch of trees that went down on power lines, and they grew together into a very large and intense fire. And one thing I wanted to show here was, this is kind of a view of fire intensity or fire severity. The Forest Service, any fire that hits Forest Service land, they do a kind of a post remote sensing analysis of the intensity of the burn by looking at the vegetation damage. So you can see the reds here is over 75% canopy cover mortality. Now this is a kind of a rapid, this is their rapid assessment program. So it usually takes a couple of years to really determine what vegetation actually is going to come back and which one is dying is dead. And so I thought this is probably I like this video. This is not of the Beachy Creek, but this is of a flyover of the Riverside fire just north of there. And that's Fish Creek drainage running off to the north that runs into the Clackamas. And so this, I just wanted to show the kind of mosaic. Some hillsides you can see there in the distance, just completely blackened, but this ridge top in front of us here, a lot of it remained viable. So this is quite a patchwork, and you can kind of see that in those fire severity mosaics that they come up with. And there's Mount Hood in the distance. And so there's the fire, that's the fire severity mosaic, the ravage raster drawn over the landscape in the same area. So you can kind of see the kind of patchwork severity within that fire perimeter, which is why we call it exposed rather than burned, because a lot of it doesn't actually burn. And that's all we got. 20 minutes on the nose. Any questions, anyone?
All right. So we're not really getting a whole lot of questions. There has been in the chat, there's been some discussion about the fire risk models and the background for those fire risk models. But we do have a good question from David Waltz. Can you distinguish between canopy and soil burn intensity in these simulations?
We cannot. And an important thing to note is we do not have the fire intensity for each fire perimeter. These were the national FSIM, large fire simulator runs. And it's just it's this huge amount of data to try to maintain fire intensity for every single perimeter. So what Chris showed was the average across all 10,000 simulations. So it's sort of one layer. We do not have that information fire by fire, which would be really interesting, important to have. Kind of relates to Kevin's question about, or point about scale, that, you know, when you scale up, you kind of lose the ability to dig down and look at some of these things that are really important. And we are trying to work with the Forest Service now to integrate some more of that information. There has been work, I think it's the watershed erosion potential project, if I have it right, looks at post-fire soil erosion, and they have data available for large areas, but we couldn't use it for Oregon because there was, I think, a huge hole in the Blue Mountains. So it wasn't spatially complete, and wanted to make the analysis consistent across all of the public water supply areas. So no, we do not have that kind of level of information with these data.
Okay, and then we have another question about, can you describe what will be in the atlas and how we can find it?
John, you might be able to answer how you can find it.
I guess that's a question to me. Thanks, Mike. So we have the 159, 156. There are, by the way, a number of watersheds on the coast that had zero fire exposure risk. And so we don't have maps like what's shown on your screen right now for those. So the atlas is going to be put together, frankly, after the book gets out, because it's a timing and sequence part. But we expect that, I would expect that to be done sometime in late spring or so. And we would like to get it on the Oregon Explorer, as Lisa Gaines has mentioned for that. So we do have, let's see, it does look like there may be another question. Is it possible to add in water supply infrastructures to better identify specific risks to the water supply infrastructure?
Yeah, so we're working on integrating that. We're scaling this up to all the 12th code watersheds in the US, continental US, and we're looking at having some sort of metric about the number of intakes, public water supply yields from giving watersheds, particularly watersheds that intersect with source water protection areas. So we're looking at how we can integrate that information better in this exposure analysis.
Okay, and then are slope and aspects the greatest factor in exposure in your simulations?
So that wasn't part of this work, and it's part of it. I think, you know, there's the fire triangle. So there's lots of things that contribute to it, weather and fuels on the ground, slope. I don't know if I could say which one, and it varies. You know, this is a statewide assessment, so I don't think I could say overall what the one driving factor was.
Okay. And then another observation and question, recent studies have been conducted on the relationship between forest land management and fire severity that demonstrate that young monoculture plantation stands tend to burn more severely than complex older forest. Is this something that forest managers should be considering in regards to watershed health in the context of future fire seasons?
Yes. Yes, and I know Anna Barros, who's the wildfire specialist at the Washington DNR, is looking at trying to understand with empirical data, so fires that have actually occurred on the landscape, whether fires are selecting different types of ownerships, and are they, are they more preferring wilderness because of the way that wilderness is managed? And so it's a very complex problem, but yeah, all of these pieces need to be part of how we go about understanding how to manage fire better.
Okay. A final question is, if left on the landscape, aren't burned logs on the ground ecologically beneficial, as they help retain sediment and essentially become stored carbon water filters?
That is not a question for my level of expertise. I don't know if Kevin wants to jump in or someone else. I cannot answer that question.
And I don't hear Chris popping up for it.
Oh no, that goes double for me, right?
No, so so there has been some good work on that that I would recommend folks take a look at Chapter 7 in the Trees to Tap report, where we did evaluate natural organic matter, particularly in relationship to disinfectant byproducts, and there is some good research on the inputs of natural organic matter after fires. So I think with that, we'll pass it along to Emily Jane Davis, who's going to introduce the next session on the Ashland case study. So EJ, take it away.